There is some soldering again for lab 4, homework 4, I'm sorry. And the due dates, yeah, I shouldn't skip past that. So again, we have 2 checkoffs that are due next week by 5 o'clock, March 29th. And actually, it's really just one. Question 2 is your soldering again, okay? And it's not much soldering. You're going to actually add a little battery pack to your green board. We're going to be driving, in question 3, little RC servos. You guys, you may have seen them kind of around the lab. These little RC servos are for hobby remote control cars and remote control airplanes. That's why they call them remote control servos, RC servos. And it's not a good idea to power those RC servos with your USB power. Okay? So what I'm going to do is I'm giving you a battery pack. You're going to have to go buy yourself some AA batteries. Okay? So you'll need 4 AA batteries once you want to get your RC servo running. And then we'll show you how to plug the RC servos. But on the RC servo, you'll see it's labeled, the 3-pin headers there are labeled where ground is. And in your RC servo, almost always, well, I think the ones I have in lab that I'll be showing you, almost always the ground wire is black. Okay? There probably are some out there that have another color for ground, but I'm pretty sure ours ground is black. If you're uncertain, ask me. But you're really just, all you're soldering is this little area of the board. 2 3-pin jumpers, 2 2-pin jumpers, a little jumper wire there, and then your battery pack. So pretty nice and easy, quick soldering exercise. And then exercise 3, and again, you could get started on this right away because again, it's just PWM. So it's just a matter of driving these RC servos with the correct PWM signal. Have you ever seen people flying RC airplanes, right? They got this thing in their hand they call the radio, right? And for ages, however long they've had RC airplanes, they've been around forever, haven't they? And what they send across, which is kind of interesting, I'm not going to get into all the details, you can look at this online, but what they send across, if you have, sometimes if you've played with those, they call them like 8-channel radios or 6-channel radios. I don't know if you've heard of that. But anyway, that just means how many signals they can send and what's being sent wirelessly. And one of the reasons it hasn't changed much over the years just because it's just really solid and you don't get a lot of mistakes or hiccups in the wireless interface because all it's sending is high and low digital signals for a certain amount of time. So actually what's coming out of that radio, we're not using this radio, I'm just trying to get you to see how we drive these servos, but this is your little radio, right, with the joysticks. Is that a good picture of a radio with your hand? And that wireless signal is going to the receiver that's on the airplane, okay, and it's got a little antenna hanging off of it, okay, and then what's on that receiver, if you've ever seen one, is a bunch of 3-pin headers. And if it's an 8-channel, do a couple more. I'll do them all here. If it's 8-channel, then there's 8. Did I do 7 there? Then there's 8 columns, or whatever you want to think of it, of 3-row pin headers. And so you could connect. That's what our RC servos have. They have 3-pin headers, female headers. And you would plug all your RC servos into that receiver. Okay? Or, what's more important on an airplane, you plug in your speed control for your propellers. Okay? That's another channel that you can tell it to go faster, slower, all that kind of stuff. Well, so what is being transmitted wirelessly somehow, however, is a train of pulses. And these pulse widths can change. All right, so how many? 1, 2, 3, 4, 5, 6, 7, and there'd be one more. 8, whatever. All these can have different widths. Okay? Then what this receiver does on the airplane is breaks these 8 widths out into a PWM in a sense that goes to each individual 3-pin row connection. So this signal is then broken out to, let's say this one here, is this pulse width repeats every approximately 20 milliseconds. They say all radios are slightly different, so some could be a little longer than this, some maybe a little bit shorter than that. And then that's signal 1, and then signal 2 is, again, it's broken out to another signal that's right like this. And you guys looking at this shouldn't scare you at all. We know how to make a PWM signal that looks like this, don't we? Okay, it's just, this is our carrier frequency right here, and then the width is a duty cycle, isn't it? Okay, and so what this command, the way the RC Servo works, at least the most common RC Servo, the one that most people use and all that kind of stuff, there's all sorts of different versions out there, but this is the signal that an RC Servo takes. And what we're going to find is, again, if it's repeating every 20 milliseconds, that means it's got a 50 hertz carrier frequency. Right? 1 over 0.02. Agreed? All right, that's 50 hertz. And then what it takes is the RC Servo, all it can do, and you'll play with it when you get one, it can go from, we'll call it minus 90 degrees to 90 degrees. That's it. It's got about 180 degrees of movement. That's it. And what's inside this little thing is, it's actually a servo. It's a feedback controller. So I'll draw it really poorly here, but it's a rectangle piece with what pops out here is the shaft for driving. And then there's a circle connection. And then there's a bunch of gearing inside here. I mean, it's a huge gear ratio that goes down to a motor. All right, so your motor's sitting over here inside the little RC Servo, and it's got gear heads, and it's geared to this motor. That's what people just love about these. They're super light, and they have quite a bit of torque. Okay, and so they work great for little, steering your remote control car and all this kind of stuff. The problem with them is just huge amount of friction. But anyway, they are a servo, so when you command it, it'll go to that position and just stop there. Go to another. So there's feedback inside here also. It depends on where they put it. They can gear it to it, but there's also a potentiometer here that its shaft is rotated by some of the gears too. So this is the feedback. This is your position where you are. A pot, right, is a knob, right, on an instrument. And as that rotates, it's a position. It's an angle where that's twisted to. So inside here is a controller. We don't even care about it, but they have a controller in here that's taking this pulse as its position command. Okay, so it's told, okay, I want to go to 0 degrees. Well, what is 0 degrees? It's approximately, you'll find, about 8% duty cycle is 0 degrees for a servo. Now, these things, if you really wanted it exactly 0, you'd have to adjust it. It's not exactly 8% duty cycle, but it's pretty close to that. And that's what the homework talks about. But anyway, so, and then and so that's approximately 8% duty cycle of, is about 1.5 milliseconds, I think, somewhere around that range. And so your pulse width, this width right here, determines your position, your angle. So let's say for now, you can play with me, you can figure it out better. This is approximately 8%. And then the position minus 90 command to this is about 0.6 milliseconds. Or we're going to call that 4% duty cycle. Okay? And so this is an angle of, 0.6 is 90 degrees, minus 90 degrees. This is approximately 0 degrees on the servo, and a pulse width of a little bit more than 2.5 milliseconds, which we're going to call somewhere around 12% duty cycle. That's positive 90 degrees. Okay? And so just by varying that pulse width, which in a sense is varying the duty cycle of your square wave, you can command the servo to different angles. And if you keep on sending it the same duty cycle, say always 8% duty cycle, it's going to stay right at that angle and hold it pretty tight. It's even kind of hard for you to move it by hand since it's such a heavy gear ratio. Okay. Anyway, so you can get started on this right away, get your board soldered up, and start PWMing an RC Servo.